now we go for an example. Okay, for example, we have isotopic notation for sodium. Okay, so for sodium, okay, if you look at this isotopic notation, okay, they have 23 nucleon, 11 proton. And if they ask you to identify the subatomic particle, okay, you should remember that nucleon is not part of subatomic particle. Subatomic particle is only proton, neutron, and electron. Okay, so for this case, number of proton refer to this value, which is 11. Okay, number of electron, because this atom is a neutral atom, number of proton should be equal to number of electron. So number of electron also 11. And how about neutron number? Okay, so you should remember that. Okay, we recap again. Okay, nucleon is equal to proton plus neutron. Okay, so here we already got 23 nucleon, 11 proton. So number of neutron, it should be, how is it? It should be 12. Good. Okay, so this is how you want to identify the subatomic particle if they give you the isotopic notation. But sometimes they can give you subatomic particle and they ask you to write the isotopic notation. Okay, it can be vice versa. Okay, the same thing, not the same concept. Okay, look at this, the second example. Now I give you about the ion of Na, the cation of Na. Why I call it cation? Because it's positively charged. Okay, you should remember that positively charged is made from when atom is release electron. Alright, so the only thing that involved when atom convert to ion is only electron. The difference is only in number of electron. So for the proton number, it should remain the same, 11. Okay, so proton number should be 11. Alright, so how about neutron number? Is it involved for the forming an ion? Nope, right? Because to form an ion, okay, whether you accept electron or you release an electron. So for this case, cation, it should release an electron. So neutron number also 12. Okay, so when the neutron number is also 12, okay, the nucleon number should be 23 as well. Because nucleon number is equal to proton plus neutron. But how about number of electron? Okay, so now number of electron would be different from normal atom because they are cation here. So cation now is 1 plus, which means it release 1 electron. It lost 1 electron. So the number electron now it should be, okay, atom 11, ion it should be 10 because it already released 1 electron. Okay, that's how you want to write the isotopic notation for an ion. Alright, next. Okay, but sometimes you're gonna come across for this case. Okay, for example, I got copper, Cu. Okay, Cu6329. So which mean it got 29 proton. Okay, and 63 nucleon. Am I right? But you're gonna find something like this. Okay, it's also copper, Cu. It also have 29 proton, but different number of nucleon. Can you see this? Okay, these two atoms are the same atom. Both are copper. Okay, but they have different number of nucleon. So what is this? So this is we call as isotope. Okay, this is isotope. So what is isotope actually? Okay, there are two or more atoms of the same element. Okay, two or more atoms of the same element. Okay, that have same number of proton. Okay, same proton, but different number of neutron. Okay, all the things that I circle and highlight should be written if they ask you the definition for isotope. Alright. Okay, the last part for the first lesson 1.1 about atom and molecule. Okay, for example, if we got the copper, okay, so copper, we put this atomic particle into table. Okay, proton number should be 29. Both have 29. Okay, because they're isotope. Okay, how about number of electron? Okay, number of electron will be the same because it's in an atom. So 29 as well. 29 for copper 63, 29 for copper 65. Okay, but they have different number of neutron because they have different nucleon number. Can you see this? So for the copper 63, neutron number should be 34. Okay, why 34? Because 63 minus 29. And how about copper 65? Copper 65, the neutron number should be 36. Okay, so what is the difference between copper 63 and 65? Okay, so because they have the same number of electron, can you say this? Okay, so both copper, okay, should have same chemical properties. Okay, because they have the number of electron, so they will react the same way. Okay, but the mass for both copper are different because the first copper is 63, the second is 65. So they're going to have different physical, different physical properties. Okay, the similarities and difference between two isotopes. Okay, they're going to have same chemical properties because they have same number of electron, but different physical properties because they have different number of nucleon ataupun different number of neutron. Okay, what is the mean by different physical properties? They're gonna have, maybe they're gonna have different boiling point or different melting point, something like physical thing lah. Alright, so I think at the end of this video, you should answer the tutorial question from number 1 until number 4. You should be able to answer number 1 until number 4. Alright, have a try.